Okay, I wanted to work through the 6 problems that you guys just tried on section 10.2, numbers 13 through 18. Again, they don't look too bad to start with, but they're a little bit tougher than it at first appears. Okay, so I'm going to work through them, and please compare what I do to what you've already done to see how we match up. Okay, number 13, well, first of all, the directions ask us to find the number of possible 5-card hands that contain the cards specified. And they're taken from a standard deck of 52. Now, what I've tried to do in your Google Classroom is I've tried to attach a picture of a deck of cards. So if you're not familiar with a deck of cards, you can look at the picture to see what's there. Okay? So number 13 asks us to count the number of possible 5-card hands that would have 5 face cards. Now, in all of our problems, it's not going to matter what order the cards are dealt in. So all of our problems here in these 6 are going to be combinations. So the question to answer is, how many combinations of 5 face cards can we have? Well, the total is not 52 because we're not picking from all 52 cards. We're only going to be picking from the face cards. The face cards, hopefully obvious, are the cards that have a picture of a little person, either a king, queen, or jack on them. So there's actually a total of 12. And from the 12, what the problem's asking me to do is pick 5. So it's asking me to pick 5 face cards from a total of 12 in a deck. So the formula would say then that that's going to be the total number of objects factorial divided by how many at a time factorial multiplied by the difference factorial. And I'm going to stop showing you guys the formula. You guys can punch it out at any time you need. I'm just going to go directly to the math. And so the correct value here would be 792 ways. So you could have 792 possible 5-card hands where you have all 5 being face cards. Okay? All right, number 14 asks, in how many ways can you have 4 kings and 1 other? So now we're linking events together with the word and whenever we have the word and, the operation we're going to perform is multiplication. And so we're going to be counting then the number of ways that I could have 4 kings in my hand and the number of ways I could have 1 other card in my hand. Okay? Alrighty, so let's give it a try. How many kings are in a deck? So how many total kings are in a deck? 4. And how many are we being asked to select? We're being asked to select 4. So how many ways can you select 4 kings from the 4 kings? Okay? You might already know that answer. And then 1 other card, meaning 1 card that's not a king. How many cards in a deck are not a king? 48. And how many are we being asked to pick? 1. So again, without going into the formula, I'm just going to punch directly. The number of combinations of 4 total things selected 4 at a time is 1. And the number of combinations of 48 things selected 1 at a time is 48. So the number of ways we could pick 4 kings and 1 other card would be 48. Okay? Alrighty. And again, feel free to pause the video anytime you need to if you want to take a look at something or rewind. So if you want to hear it again, that'd be great. Number 15 is again an and problem. So we're linking multiple events. So the operation with and is multiplication. All right, and again, 2 events. The events are picking 1 ace and then picking 4 non-aces. All right, well, how many aces are in a deck of cards? 4. And how many are we being asked to select or pick? 1. And then how many cards in a deck are non-aces? Well, that would be 48. And how many are we being asked to select there? 4. Okay? So again, just using my calculator to punch out each of these values. Combination of 4 total objects selected 1 at a time is 4. And then the number of combinations of 48 objects selected 4 at a time is 194,580. And so when I multiply those together, remember the connecting word and tells us to multiply. When I multiply those then together, I get a total of 778,320 ways in which we could pick one ace and 4 non-aces. Okay? My number 16, again, multiple events, but this time with the connecting word or, and the operation we perform when we have the connecting word or is addition. All right? And so what we're going to do is count up the number of ways we can pick 5 hearts, and the number of ways in which we can pick 5 diamonds. All right? How many hearts are there in a deck of cards? 13, and we're being asked to select 5 of them. How many diamonds are in a deck of cards? 13, and we're being asked to select 5 of them. So we'd have to evaluate the combinations of 13 things selected 5 at a time, which would be 1,287. So for each of these, 1,287. And when we add the results together, we get a total then. Remember, add because we had the word or in the middle. So we get a total of 2,574 ways in which we could pick 5 hearts or 5 diamonds. All right, everyone doing okay? All right, next, let's finish off with the last two. Number 17 asks, count the number of ways you could have at most 1 queen. Well, that's kind of confusing because at most 1 queen, we'd have to phrase that a little bit differently. We know that might be multiple events, but is that using the word and or the word or? Well, at most means no more than that. So 2 is no good, 3 is no good, 4 is no good. At most means, so what's equivalent to at most is picking 1 queen or 0 queens. And the reason I left the blanks, what goes along with that? Well, if I have to pick 1 queen, how many other cards do I have to pick? 4. And if I pick 0 queens, how many others do I have to pick? 5. So this becomes a little more complicated. At most 1 queen means 1 queen, excuse me, with 4 others, or 0 queens with 5 others. Okay? And so to do that calculation then, the or, again, tells us to add. How many ways can we pick a queen? Well, there's 4 queens in a deck, and we're supposed to pick 1. But what goes along with that is 4 others. Well, how many other cards are in a deck? 48, and we're supposed to select 4. And then with our other option, again, or is addition. With our other option, how many ways can we pick 0 queens? Well, there's 4 total queens in a deck, and we're supposed to pick 0 of them. And then from the 48 other cards, we have to select 5. Right? So please take a good look. Going across, I'll pick my laser pointer here. We have the number of ways we could pick 1 queen with 4 others. The number of ways we could pick 0 queens with 5 others. And now we just have a whole bunch of computation to do. Again, I'm just going to use my calculator for these. The combinations of 4 selected 1 at a time is 4. 48 selected 4 at a time, that would be 194,580. Combination of 4 things selected 0 at a time is 1. And 48 things selected 5 at a time is 1,712,304. So when I do the multiplication and addition, what I would get as a result is 194,580 times 4 plus 1 times 1,712,304. And I'm just going to take a good look. I think I punched that okay. So I'd end up with 2,490,624 ways in which we could pick at most 1 queen. And then to finish off, what we'd have to do is calculate the number of ways we could pick at least one spade. At least one spade. All right, again, the wording, this at least, is confusing. So at least one spade, what's another way in which we could write that? At least one means, well, if we had one spade or two spades or three spades or four spades, and remember we're having 5-card hands, or 5 spades. But unfortunately, and here's why I left all of the gaps, when we're picking one spade, how many others would we have to pick? 4. When I pick 2 spades, how many others would I have to pick? 3. When I pick 3 spades, how many others would I have to have? 2. If I pick 4 spades, how many others would I have to have? 1. And if I pick 5 spades, how many others would I have to pick? 0. So you can see it actually turns out to be a terrible looking problem because we have 1, 2, 3, 4 ors. And so we just have to start crunching it out. How many spades? Well, there's 13 total spades in a deck, and we're supposed to select 1. How many other cards are in the deck? 39, and we're supposed to select 4. So just let me do some arrows here so you can see where these are coming from. And then the OR tells me to add. Now I'd have to do 2 spades and 3 others. So from 13 spades, I'm supposed to pick 2. From the other 39 cards, I'm supposed to pick 3. Or from the 13 spades, pick 3. And from the 39 other cards, pick 2. Or from the 13 spades, pick 4. And from the 39 other cards, pick 1. Or, last one, from the 13 spades, pick 5. And from the other 39 cards, pick 0. Okay? Again, we just have a whole bunch of values here that we need to punch out. So it's going to take me just a minute to do that. So 13C1 is 13. 39. C4 is 82,251. 13C2 is 78. 39C3 is 3,000. Nope, sorry, typo. 1,939. 13C3 is 286. 39C2 is 741. 13C4 is 715. 39C1 is 39. 13C5 is 1287. And 39C0 is 1. So I need to multiply all of these pairs of numbers together and then add the results. And when I do all of that math, you guys feel free to double check me. I punched out to be 2,023,203 ways in which we could pick at least one spade. Okay? So those are the 6 problems I wanted you to work over on your own. Now there's going to be a third video that takes care of the second part of the section, which is something called Pascal's triangle. So if you want to go back and look at any of the problems 13 through 18 again, and then take a break, and then come back and take a look at the third part of this section.